So it's okay.
So if this is all H.
Hi, I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in today. This is another in our series of Chalk Talk videos on various technologies that are affecting the storage industry. I'd like to thank the sponsor of today's video, STEC, for helping us talk about optimizing MLC for the enterprise. So MLC is a form of solid-state disk. The first thing to do is kind of set up and talk about why are we seeing solid-state in the news everywhere in the IT arena today, right? Well, the number one reason is you got performance problems. And performance problems, to me, the biggest impact of a performance problem is some poor IT guy is spending all day troubleshooting a performance problem, trying to adjust things to squeeze a little bit more performance. And the answer is solid-state disk. It can solve almost every storage performance problem that you have. So let's look at where solid-state has been pretty well adopted. One is sort of the database methodology. The way a database works is you've got a series of files, and typically a couple of those files get very active, log files, things like that. Well, if we had solid state, we could take those files and put them inside the solid state drive and then give almost immediate access to those very busy files and dramatically improve performance. That's kind of the legacy use case, and maybe to a large extent still today it's by far the most popular one that we see. It's very easy to cost justify. If you can quadruple the amount of transactions that you can handle, pretty easy to cost justify that expense. The second is that we're seeing grow is the use of solid state where we're going to use it more as a caching layer. So instead of worrying about a few files, we'll cache everything up into this area. So anything that's being active now goes into that cache. So it gives us a broader use case. It eliminates some of the fine-tuning requirement because the software is analyzing what's active and not and storing it in solid state. Another area we're seeing some growth is in just as being replacing the storage and the server altogether and just booting directly off a solid state. So we're seeing that a lot. Clearly, the faster you can reboot a server, the better. Also, it'll help with, especially in a virtual environment where you're paging out to memory. Well, if you're paging out to a solid state drive instead of a hard drive, that's going to help performance a lot. So there's a lot of payoff here, so why aren't we seeing broad adoption of solid state? Well, I think the key reasons are right here. It's going to be endurance and price. The endurance of solid state is always a concern for people, as is the price of solid state storage. And if it's a lot more expensive, it's just going to limit adoption. So vendors are really focused on trying to drive those two aspects down. So what's the endurance problem? Well, solid state has, like any technology, will wear out over time, and it creates errors. But solid state's a little bit unique in that writes are bad, essentially. That the more you write to it, the quicker it wears out. And so vendors have to manage the write process. And the way that looks, if I kind of expand up a NAND here, let's say those are cells within our NAND, and then you always have a controller that manages how that NAND is written to. And so at a very primitive level, what it does is, since these things will wear out over time, one of the very simple things it does is something called wear leveling that makes sure that we move and use all of these cells in their native state or evenly. So that helps us with that. But the more you write to a solid-state drive, the quicker it wears out. And the reason for that is twofold. Number one, a write itself hurts, but as you fill all these cells up, you have to clear them out to write more data to them. Well, to clear out a cell takes a higher charge of energy than does an initial write to the cell to just write data to it. So you sort of have this worsening effect. And the way that will manifest itself is as this data is being done, what will happen is the controller, many times in the background, will go and clean out eligible cells with these higher charges. But these higher charges further reduce the life expectancy of the drive itself. So those are big issues. And just a quick thing here, this is not, the fact that you never actually see a drive fill up is not the problem. What happens is you write to these drives and data is maybe marked as eligible for deletion but not necessarily deleted. So it's the total writes to the drive, not how much actual data is physically on the drive at any moment in time. So that's a lot of the endurance issue. Then there's price, right? This is just more expensive than the hard drive technology. And we've seen flash really take two forms so far. One is SLC memory and the other is MLC. And the L stand for layer cell, and this is single layer and this is multi-layer. This is in multi-layer, what we're basically doing is fitting more data on that cell. And so that means it wears out quicker. The life expectancies of these will change over time, but the SLC technology is roughly 10 times more. It's up around 100,000. And so to overcome the endurance issues that we talked about, a lot of the major manufacturers have sort of played it safe and gone with SLC as a starting point. The problem is, of course, that's a higher priced number, and so that drove this sort of price delta that we're already dealing with up even further. What you'd really want to do is figure out a way to use MLC because it's so much more cost effective. So is there a way to really increase the life expectancy of MLC? And that's really been the focus of a lot of the workarounds that we've seen in the market today. So, for example, one of the things we've seen with especially all-flash systems, which are storage systems that have no hard drives in them, is the rapid adoption of deduplication and compression technologies. Nothing wrong with those technologies, but they do add a burden to the system that has to be managed and things like that. And the intent being to fit more data in less space and try to eliminate some of the write traffic. And so what we've seen essentially is in the all-flash systems is this sort of lean toward an MLC type of technology, leveraging deduplication, or the SLC, which again drives the price up. Now another variant is a technology or a version of NAND called eMLC, and it has a life expectancy that's better than MLC, but not quite as good as SLC. It's probably in the 30,000 program erase cycle expectancy range. eMLC, the way it gets there, this longer expectancy, is it slows down the write. And so we don't have the energy issues that we do before, because now we can write to it slower. So the effect of that is kind of interesting. We're taking a technology that's almost always bought for performance and making it slower so it lasts a little longer and is a little bit more affordable. From a price standpoint, it kind of falls a little bit in the middle of these two. And a lot of people have adopted that, and that's fine. But we really don't get back to the core problem. And we think the solution is really to add intelligence to the overall process. And so what that means is really making this controller smarter than it is, at least off the shelf today. So a great example is companies like STEC and their cell care product. What they can do is they can change the charge that's being written to these flash cells, and as data is being written to these drives, they can use less energy than other technologies do, depending on the state of the drive and the state of that particular cell. And so it has an adaptive sort of intelligence that as the drive ages, it can adjust the level of this charge that has to happen during an erase cycle. So using greater intelligence gives us, in the MLC case, a much better life expectancy of the drive. For example, STEC and their cell care technology, they'll report about an 80K write cycle capability. And again, remember, this was around 100K, and this was about 30K. So you're getting significantly better than eMLC. You're not having to slow down the speed at which you write data. And you are getting close to this sort of enterprise level drive, but you're doing so at the most affordable price, at least thus far, in flash technology. So it's a really good combination. Now we can take MLC, drive the price down better, and really expand the use case across all different types of products. So this is an important technology, and we think just adding intelligence at the controller is a really good way to broaden the adoption of solid state. I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in for today's video, and again, I'd like to thank the sponsor of today's video, STEC.